In this video, we're going to focus on the many different ways of finding the area of a triangle. So in our first example, let's say that we have a right triangle. Let's say the base is 10 and the height is 12. Go ahead and find the area. So the first thing you need to know is the formula to use. For any right triangle, or any triangle that you know the base and the height of, the area is simply 1/2 base times height. So for this example, it's 1/2 times the base of 10 multiplied by a height of 12. Half of 10 is 5, and 5 times 12 is 60. So that's the area of the right triangle on the left. It's 60 square units. Now what about finding the area of a triangle that looks like this? Let's say if you're given a base of 8 and a height of 6. What is the area of the shaded region? Now you can use the same formula to find the area of that triangle. It's 1/2 base times height. So in this example, the base is 8 and the height is 6. Half of 8 is 4. 4 times 6 is 24. So that's the answer for this example. Now let's say if we have an isosceles triangle. That's where two sides are congruent to each other. And let's say the base is 8 units long. Find the area of this triangle using the same formula. A equals 1/2 base times height. Now I'm going to redraw the triangle. Because it's an isosceles triangle, we can split it right in the middle. So this side is 4 and the other side is 4 as well. And this is 5. Our goal is to find the height of the triangle. If we could find the height, then we can easily find the area. So I'm going to focus on the right side of this triangle. If we just focus on the right side, notice that it forms the right triangle, with the hypotenuse being 5 and the base is 4. So we got to find the missing side. Whenever you have a right triangle, you can use the Pythagorean theorem to find the missing side. Let's call this A, B, and C. So in this example, we know that A is 4, C is 5. So we can use this equation. A squared plus B squared is equal to C squared. Our goal is to find the value of B. 4 squared is 16. 5 squared is 25. 25 minus 16 is 9. And to find the value of B, we need to take the square root of both sides. The square root of 9 is 3. So therefore we have the height of the triangle. B is 3. So now let's draw the original picture. So we have a height of 3 and a base of 8. So really all you need in a triangle that looks like this is the base and the height. Once you have it, you could find the area of the whole triangle. So it's 1/2 base times height. The base is 8, the height is 3. Half of 8 is 4. 4 times 3 is 12. So it's 12 square units. Now what about this example? Let's say if we have an equilateral triangle. All sides are the same. Go ahead and find the area of this triangle. Now, if you decide to use the same method, we know this side is going to be 10, and we're looking for the height, so this has to be 5. The left side is 5 and the right side is 5. It has to add up to 10. So we could find the missing side. So using this equation, a squared plus b squared is equal to c squared. A is 5. We're looking for b. C is 10. 5 squared is 25. 10 squared is 100. 100 minus 25 is 75. So b is the square root of 75. How can we simplify the square root of 75? 75 is basically 3 times 25. And the square root of 25 is 5. So this reduces to 5 root 3. So now we have the height of the triangle is 5 root 3. So now we can use this equation. A is equal to 1/2 base times height. So we have a base of 10, a height of 5 root 3. Half of 10 is 5, and 5 times 5 is 25. So the area is 25 square root 3. Now that's one way to get the answer. There is another way. Whenever you have an equilateral triangle, where all sides are the same, you can use this formula. The area is the square root of 3 divided by 4 times s squared. So in our example, s is 10. So if you know this formula, you could just go ahead and use it to get the area. Just plug in the length of the side. So it's root 3 over 4 times 10 squared. 10 times 10 is 100. And 100 divided by 4 is 25. So this will give us the same answer, 25 square root 3. Now let's say if you have a triangle where you have the value of 2 sides and the included angle. What can you do to find the area of this triangle? Sometimes you might see it as side, angle, side. You have this side, and then you have the angle, and then you have the side. Before we can use the formula, we need to define a few things. Let's call this angle A, angle B, angle C. Across angle A, you have side A. Across angle B is side B. Across angle C is side C. So you need to use basically an equation that deals with sines. So the area is 1/2 times the side A times side B times sine of angle C. So that's the formula that you want to use. In our example, B is 10 and A is 15. So it's going to be 1/2 15 times 10 times sine of the angle on the inside, which is 30 degrees. Now 15 times 10 is 150. So we have half times 150, and sine 30, if you type it in your calculator, make sure you put it in degree mode. Sine 30 is 1/2. Now 1/2 of 150 is 75. So now we have 75 times a half, which is going to be 75 over 2, or you can write it as 37.5 as a decimal. So that's the answer for this example. Now let's say if we have a right triangle where this is the base, this is the height, and the included angle is 90 degrees. Let's start with the same formula that we used in the last example, 1/2 A times B sine of C. So in this example, we could say that A is the height. Let's call A the height. So I'm going to replace A with H. And B, let's call it the base. And then we have sine of the angle, which the angle is 90 degrees. Sine of 90 is 1. So therefore, you get the area of a right triangle, which is 1/2 base times height. So this equation comes from this equation. Sine 90 is simply 1. But if the angle is anything different, then you want to use this equation. Now let's try one more example. So this time we're going to have a triangle with 3 different sides. So it's SSS, side, side, side. What can we do to find the area of this triangle? Now there's something called Heron's formula. And to apply it, you need to find S, which is basically 1/2 of the perimeter of the triangle. It's A plus B plus C divided by 2. So we're going to add 9, 10, and 11, and then divide the whole thing by 2. 9 plus 10 is 19. 19 plus 11 is 30. And 30 divided by 2 is 15. So now we have the value of S. Once you find the value of S, now you can use that to find the area of the triangle. So here's the formula. The area is going to be the square root of S times S minus A times S minus B times S minus C, where A, B, C are the 3 sides of the triangle. So this is going to be 10 times S minus A, 10 minus 9, times S minus B. Actually, S is 15, not 10. I don't know why I put 10. So let me just make that correction. So S minus A is going to be 15 minus 9. S minus B is 15 minus 10. And S minus C is 15 minus 11. Fifteen minus 9 is 6. 15 minus 10 is 5. 15 minus 11 is 4. Now we need to simplify this answer. So if you don't have a calculator, here's what you could do. 15, you could break it into 5 times 3. 6 is 2 times 3. And 4, well, that's just a perfect square, so we can leave that alone. So we have the square root of 4. 5 times 5 is 25, so I'm going to write that as the square root of 25. 3 times 3 is 9, and then we have a 2 left over on the inside. The square root of 4 is 2. The square root of 25 is 5. The square root of 9 is 3. 2 times 5 is 10. 10 times 3 is 30. So the area, the exact answer, is 30 square root 2. So that's how you can use Heron's formula to find the area of a triangle when you have all 3 sides. If you have a triangle where the 3 sides are the same, it's an equilateral triangle, you could simply use this formula as we've discussed earlier in the video. But if the sides are different, then use Heron's formula.